Let's look at this next question that says appliance is connected to the main supply. The main has the potential difference of 230, and charge transferred is this. The charge flows through the appliance. That now energy, we're going to work out energy is equals to charge, which is 13 times the potential difference, which is 230. If you work it out, let's see what is going to give us. 13 times 230, which is going to give us 2990 joules. Write down the equation that links charge flow. So we know that charge is equals to current times time. Charge is equals IT, and the fuse melts when we have a charge of 1.52 coulombs, and that passes through 0.4. So calculate the current which the fuse melts. So we can be able to say current from this equation. We can be able to say current is equals to charge over time, which is 1.52, which is divided by what? 0.40 seconds. Then we can be able to put it inside the calculator here. 1.52, 0.40, and that is going to translate to 3.8 amperes. 3.8 amperes, and then you can be able to transfer it down here. 3.8 amperes. Don't write it because already it's written here. 3.8 amperes as the current. Guys, just follow for more. While doing physics, you're going to meet questions like this, whereby you are told to draw a ring around a device which can be represented by this particular graph we have here, and this becomes a filament lamp. Looking to the next part of the question, here you are told the figure shows a circuit containing 6 volts. We have 2 resistors in parallel like that. What is the potential difference of X? When components are connected in parallel, they have the same potential difference as the source. So which will mean that this is going to be 6 volts. Calculate the resistance of X. If you want to find the resistance of X, you can see the current that is going to X. The current that is going to X is 2 amperes. So which means that resistance is equals to voltage over current, right? You have to remember that. And that means it will be the voltage is 6 and the current that is going there is 2, and this is going to be 3 ohms. Yeah, so X has 3.0 ohms. What is the current in Y? When the current that is getting here is 3, and if 2 has gone this side, to mean 1 ampere must go this side, because the current that was getting into the junction is 3 amperes. As broken into that, 1 must flow this one, and that is 1.0 amperes. Calculate the resistance of Y. Resistance, we have said, is voltage over current over current, and our voltage is 6 divided by 1, and that is going to be 6 ohms. And then you are done with that. The next question that is asked here, so we were talking about this resistance, right? We were talking about this circuit here. Now look at this question that was asked. The student connected 2 resistors in the diagram above in parallel. What will happen to the total resistance? When resistors are connected in parallel, it means now that this circuit is going to have less resistance, because the resistance of the circuit is going to decrease. So this is exactly what we're going to say here. Give the reason, because I want you to understand that the total resistance is going to be R total is going to be 1 over 3.5 plus 1 over 4.0, then negative 1. That is how you can be able to work out this resistor. Then I'm going to tell you the reason as to the reason that you're going to write over this. Yeah, the answer, let's first find the answer of the total resistance, and then this is answer negative 1. This is going to be 1.87 ohms. You see, now this is the resistance that we are going to have in this particular part. This is the value of the resistance that we're going to have. So the reason we're going to give is that the current will be higher, yeah, for the same PD. So we're going to say here, if you are asked the reason, you're going to say current will be higher for the same potential difference, yeah. Or you can also say that this is one of the answer you can give, or you can say that total resistance in parallel is always less than the smallest. Is always less than the smallest. Always know when resistors are connected in series, the resistance that you get as the total when resistors are connected in parallel, the resistance you get always should be less than the smallest resistor. What is the correct symbol for a fuse? This is the fuse. In this case, this is a diode GCSE level of AQA. So the first question that we are asked here is to draw a diagram to show how 1.5 volt cells should be connected in order to give a potential difference of 4.5. You need to understand that we have two types of connections, whereby we have parallel, also we have series. So if you connect cells in parallel, you are going to have the same amount of voltage. But if you connect cells in series, it will mean that you are going to have a total sum. The total sum of all the voltage that you have will be equivalent to the number of cells that you have in that case. So in order to draw that, we need 3 cells in series. So this is all in the connection. So we are going to say, if you have cell connected like that, we shall have a cell connected like that, we shall have another cell connected like that. So we end up having the 3 cells connected in that manner. So we are going to say that for us to achieve that, we need what? We need 3 cells like that. So which means that these cells are connected in series. Then we shall have that the longer side, this side is going to represent the positive terminal, and this is going to represent the negative terminal. So that's basically what you do in order for you to answer this particular question. Now, a student builds the circuit in the diagram below, and then you can see the current that is flowing through in this circuit is basically a current of 1.6 amperes. So which means that there is also a voltage supply of that, and we have 3.5 ohms well represented here. So how are we going to answer the questions in this particular part? Let's see the question that was asked here. We're going to see the question that was calculate the total resistance, and we are given the formula that resistance is equal to the potential difference divided by the current. So meaning the total resistance is going to be R is equal to the total voltage divided by the current I, and in this case the total voltage is 12 and the current is given as 3 point what? Let's see. No, the current is 1.6. 1.6. So if you're going to put that in the calculator so that we can be able to work it out, we are going to get our answer equivalent to what? 12 divided by 1.6, which translates to 7.5. 7.5 becomes the answer for this question. 7.5 ohms. So this is 7.5 4.5. Now the resistance of P is 3.5. Calculate the resistance of Q. So in order to work out the resistance of Q here, what you need to realize in this particular question is that these two resistors are in series, and if resistors are in series, the total resistance will be the sum of these resistors. So if we have gotten the total resistance is 7.5 in this circuit, then for us to get this resistance of Q, we are going to say it's 3.5 plus Q should give us the 7.5 that we got on the other side. So let's work it out so that the examiner can be happy. So this is going to be 3.5 plus the resistance of Q should give us 7.5. So which means that our Q is going to be 7.5 minus 3.5. If we subtract here, we are going to get 4.0 ohms as the resistance. 4.0 ohms. Already we cannot write this because already it's written here, so don't make that particular mistake. The current in the circuit is 3.5 amperes, the potential milliamperes, the potential difference is 4.2. Then you are asked to calculate the resistance. We need to remember that resistance is equal to voltage over current, and in that way you have to ensure that the current is in amperes. So that's going to be 4.2 is the voltage, but the current is milliamperes, which is going to be 3.5 divided by 1000, so that we can be able to have in amperes because it was milli. Then if we work it out, we are going to say this is going to be 4.2 3.5 divided by 1000. So if we work how that, we're going to get 1200 ohms. Yeah, 1200 ohms in this case. Calculate the charge. We know that charge is equals to current times time, and in order for you to work out the charge, you're going to say that the current in this case is 3.5 over 1000 because it's milli times time, and time here should be or must be in seconds, so it will be 5 times 60 because the time here was given in seconds. So you have to ensure that you remember all those concepts, that the right units in which our unit should be, the right units. You have to ensure they are in the right units, the 5 times 60 in that case. And if we work out this, we're going to get 1.05 coulombs. We just transfer it here to make the examiner happy. No extra mark for that. In this particular question here, we are told that the circuit is shown well. Another kind of a very interesting question that is asked here is that we're supposed to work out the energy that is used to melt this fuse. So in this case, we are asked calculate the energy needed to melt the fuse wire. So you need to remember that energy is equal to mass times latent heat of fusion in this case. So in this case, we're going to say mass is 0.00175 times latent heat of fusion is 205,000. So if you work it out here, you are going to get what? 0.00175 times 20500, like that. And if you work it out, you're gonna get your answer as 358.75 joules of energy. So in this circuit that we are having here, we are told that when the temperature in X increases, resistance increases. What will happen to the circuit? So if this resistance increases, something that you need to remember is that when resistance increases, the current will decrease. So which means if resistance increases, the potential difference of X, because this still will remain in parallel, it will remain the same. Potential difference will remain the same, but since the resistance has increased, current is going to decrease. Then if the resistance of this circuit is going to increase, it means the overall resistance of the circuit is going to increase. And when there is an increase in the total resistance in the circuit, then it will mean that the total current in the circuit is going to decrease as well. So which means we are going to say if the resistance in X increases, it will mean that the total current in the circuit is also going to decrease. In this question, we are told the diagram shows the circuit used to obtain the data needed to plot the current. So why is component M included in the circuit? Component M is called a variable resistor. This is a variable resistor. So what is the purpose of it? This is meant to keep the current, to vary the current. This is meant to vary current, change the current. If you want to adjust the current, you're going to use a variable resistor. This is called a voltmeter. This is a bulb. This is an ammeter, which is used to measure current. So looking at the next question, what does the resistance of the lamp, why does the resistance of the lamp increase as the potential difference across the lamp increases? We know that resistance basically depends. Resistance depends on voltage and current. So if you are going to increase, the current, definitely the temperature of the circuit is going to increase. So resistance is going to increase because of that. So we're going to say increasing voltage. Yeah, increasing voltage, temperature of the wire or of the filament lamp, we can say filament, increases. And this because when temperature increases, it heats up, so that results in the increase in what? In resistance. So the potential difference across the lamp is this. Calculate the energy transferred. So we're going to say that our charge is 8.5 coulombs. It's provided here, times 112.0 volts. So if you just put it in the calculator, we're going to say this is 8.5 times 12, which is going to translate to 1 or 2 joules. So this becomes 1 or 2. Right, so if you go to an exam room and you are asked a question about current, direct current in that case, they are asking which box is correct. Current that flows in one direction and that is in the same direction is the correct answer. AC current keeps on changing direction. The equation which links current, potential difference and resistance is this. Calculate the potential difference. So we know that resistance is equal to voltage over current. Then from this equation we can be able to say potential difference, voltage, is basically equals to current times resistance. So in this case we have been given that equation, so you can be able to rearrange if you are given different other questions in that case. So here we are given the current of 0.4. it's well seated here, and the total resistance will be the sum of the two resistors, so that will be 20 plus 10. That's going to translate to a resistance of 30 ohms, so which implies this is going to be 12 volts. This is going to be 12 volts. Then looking at the next question, power is equals to current times potential difference. Calculate the power. So if we are working out power, we are going to take the current, and the current in this case is basically 0.4. The current is 0.4 and the total voltage is 12 volts. So we're going to say 0.4 times 12, so that is going to be 4.8 watts. 4.8 watts.